Welcome. Have you ever wondered what's really going on inside an AI like ChatGPT? I mean, it seems to just know things, right? Well, today we're going to pull back the curtain and actually build one from the ground up, you know, conceptually.
Seriously, how does it do it? How does an AI write a poem or debug your code in like 2 seconds? It can feel like pure magic. But here's the thing, it's not. It's actually all based on a few incredibly clever ideas that fit together just right. Okay, let's get into it. So, here's our game plan. We're going to follow these 6 steps to see how these amazing tools are put together. We'll start with the basics, then look at the blueprint, gather the materials, run the assembly line, and then give it a final upgrade. All right, first things first, we need a little context. The whole idea of teaching computers our language, it isn't new at all. It's been a dream for scientists for decades, and the road to get where we are today has been a pretty wild ride. It all started out pretty simply. Back in the 50s, models were basically just fancy autocompletes, guessing the next word. Think, the cat sat on the mat. Then, in the 2000s, neural networks started to get a feel for what words actually mean. A big jump happened in 2018 with models like BERT. But the massive leap to today's AI, that came from one thing, just unbelievable scale. Making these models huge unlocked skills like reasoning that nobody ever explicitly programmed in. It happened so fast. So what was the spark for that huge jump from 2018 to now? Well, it was a revolutionary blueprint that came out in 2017. It's a design called the Transformer. And honestly, it changed absolutely everything. Let's see how this thing actually works. Okay, the biggest difference is in how these models read. Older models had to go word by word by word. It was slow, and honestly, they had a terrible memory. They'd forget the start of a sentence by the time they reached the end. But transformers? Whoa. They look at the entire sentence, or even the whole page, all at once, seeing how every single word connects to every other word. It gets the full context, instantly. And that see it all at once ability, that is the transformer's superpower. Because it can see everything at once, it can split up the work across thousands of computer chips or GPUs, all running in parallel. This design is what made it possible and, affordable to train these enormous models. That parallel processing capability is the absolute key that unlocked the entire AI revolution we're seeing today. So how does it actually do that? Well, inside the transformer, there are 3 key parts working together. First, you've got self-attention. This is the star of the show. It lets the model figure out which words are most important to which other words. Then there's positional encoding. This is basically a numbering system, so even though it sees all the words at once, it still knows what order they came in. And finally, feed-forward networks help it, think about all the relationships it just found. Okay, so we've got our blueprint, the transformer. Awesome. Now, what do we build it with? What's the fuel for this thing? Well, the answer is a mind-boggling amount of data. But the AI doesn't see that data in the same way we do. The very first thing that happens is a process called tokenization. See, the AI doesn't really read words, it reads tokens. And you can think of these tokens as the Lego bricks of language. A simple word like cat might be 1 token, but a more complex word like tokenization might get broken down into 2 pieces, token and ization. So once the text is chopped up into these tokens, every unique token gets its own special number from a huge vocabulary list. The might become 464, quick might become 12114, and so on. This is it. This is the magic step that translates our human language into numbers a computer can actually work with. And the amount of data we feed it is just, it's hard to even wrap your head around. We're talking about a huge chunk of the public internet. Millions of books, articles, scientific papers, all the code on GitHub. For example, GPT-4 was trained on something like 13 trillion tokens. This gigantic library is what the model learns everything from: grammar, facts, how to reason, and all the weird ways we humans write. So we have our blueprint and we have our mountains of raw materials. Now it's time for the assembly line. See, you don't just flip a switch and turn the AI on. Teaching it is a really careful, multi-stage process that builds up its intelligence layer by layer. And it really comes down to 3 main stages. The first is pre-training. Here, the model's only job is to predict the next token over and over and over again for trillions of times. It's like making it read every book in the world just to get a general feel for how language works. Next is supervised fine-tuning.
This is where we give it high-quality examples of questions and good answers to teach it how to be a helpful assistant. And finally, there's reinforcement learning, which is where we really shape its personality to align with what we want.
This last step, RLHF, is so cool. Here's how it works. You get a bunch of humans to look at different AI answers to a question, and they rank them from best to worst. All of that ranking data is then used to train a second AI, a reward model, that basically acts as a judge. This judge then coaches the main AI, giving it points when it generates answers that we humans would like. It's how we teach it to be helpful and, safe.
Okay, so we've built our model, we've trained it. But we've got a pretty big problem. All of its knowledge is frozen in time. It's stuck in the past, right when its training ended. It has no idea what happened yesterday. So how do we give it access to new information without having to do that massive, expensive retraining all over again?
Well, we use a really clever trick called retrieval augmented generation, or RAG for short. When you ask a question about something recent, the system first does a quick search on an up-to-date source, like the internet. It then grabs the relevant bits of info and hands them to the AI along with your original question. It's basically giving the AI an open book test, letting it base its answer on fresh, real-time facts. Pretty smart, right?
And there you have it. We've gone from just an idea to a blueprint to gathering materials, running the assembly line, and even installing some cool upgrades. Let's just take a step back and quickly recap the core components that make up our brand new AI. So remember the building blocks. We had the transformer blueprint that lets it process everything at once. We had the raw materials, trillions of tokens of human knowledge. We had the 3-stage assembly line, pre-training, fine-tuning, and alignment. And finally, we had the upgrades, like RAG, that keep the model connected to the real world.
And this is really just the beginning. As researchers are pointing out, these models aren't just fancy chatbots. They are quickly becoming the fundamental building blocks for the next wave of even more capable, general-purpose AI. This is the foundation for what's coming next. So now that you've seen behind the curtain, you know it isn't magic. It's a system built on data and design choices. And knowing how it's built kind of changes the conversation, right? It goes from what can it do to what should we teach it to do? Thanks for building an AI with me today.